Okay, let's take a look at our first problem. It says draw a normal probability plot based on the following data and indicate if it appears to follow a normal distribution. Now let's go to our calculator. Then I'll do stat, go into edit, and I'll clear out L1. Then we got 3, 5, 12. So 3, 5, 12, 21, 33, 45, 52, 40, 30, 89, 40, 30, 89, 150, 172, 181, 183, 195, 198, 205, 310, 315, and 405. Okay, let me double check that. 405, 315, 310, 205, 198, 195, 183, 181, 172, 150, 89, 30, 40, 52, 45, 33, 21, 12, 5, and 3. Okay, I'm X'd out, do second mode. Now I want to go to Y equals. I want to make sure I clear out Y1. So press clear there. Then I do second, Y equals. Enter on 1, plot 1. Now I want to choose on, so my flashing cursor is already on the on, so I'll go ahead and press enter one time. Down arrow to type, and then I want a right arrow to the last type. It looks like a straight line. Draw enter on it. And then I'm going to do zoom, and I'll press 9. Okay. Now this right here says draw a normal probability plot based on following data, indicate if it follows a normal distribution. So this right here would be my graph. I'm not going to sit there and sketch it. Now you have to kind of visualize the guidelines here. This one's a little bit on the tricky side. I would tend to say, it's got a kind of a curve here. It almost looks like a y to the third type of curve. I would say this is not a linear pattern. Even though I might be able to draw my guidelines such that it fit on there, I still would not say this is linear. So the answer here, if it follows a normal distribution, I'd say no. Okay, let's look at our second example. Get my pen. Okay. Average annual precipitation for large city is 30.85. 30.85 with standard deviation of 3.6. Assume the variable is normally distributed. Find the probability that the mean of a random selection of 45 months. So here we're talking about the many whatevers. We'll have between 29 and 30.2. So here's 29 and here's 30.2. Now between that will be this right here. And since we're talking about many, then we're going to use normal CDF, our low, our high, our mean, and our standard deviation divided by the square root of n. Okay, so we'll do low is 29, high is 30.2. Mean is 30.85, comma, and then 3.6 divided by the square root, and we're talking about 45 months. So that would be our n. And now we can plug that into our calculator. So do second mode, and I'll do second vars, choose normal CDF, and I got 29, comma, 30.2, comma, 30.85, comma, 3.6 divided by the square root, so second x squared, 45. and then press enter. And we get 0.1126. And that would be our answer. Just double checking my numbers here. 30.85. Okay, that's good. Let's look at number 3. It says a mandatory competency test for high school sophomores has a normal distribution of the mean of 350. So telling us the mean is 350. And a standard deviation of 50. Top 25% of students receive $500. What is the minimum score you need to receive this award? Top 25%. Well, that implies that they're giving us this right here, 0.25 on the right side, which means this will be 0.75. We're trying to find this value here, so we'll do INV norm. The area to the left, which would be 0.75, comma our mean, comma our standard deviation. So do second vars, choose INV norm, 0.75, comma, 350, comma, 50, enter. And I'll round it 2 decimal places, I guess. Though no decimal places probably makes the most sense for this. 383.72. Okay, number 4. The average waiting time to be seated for dinner at a popular restaurant is 23.5. So mean is 23.5 with standard deviation of 3.6. So sigma is 3.6. Assume the variable is normally disputed. When a patron arrives at the restaurant, find the probability the patron will wait more than 22 minutes. Okay, so we've got 22 and more than. We're shading this way. Okay, now it says a patron. We're talking about 1. So we're going to be using the formula normal CDF, low, high, our mean, and then standard deviation. So we'll do normal CDF, our low, which is 22, comma our high, which is E99, comma our mean, which is 23.5, and then our standard deviation, which is 3.6. So do second vars, do normal CDF, 22, comma, then second, comma, 99, comma, 23.5, comma, 3.6. Enter. And we get 0.6615. And that'd be our answer. Okay, let's look at number 5. The average number of calories in a 1.5 ounce chocolate bar is 225. Okay, suppose that distribution of calories is approximately normal with sigma is equal to 20. Find the probability that a randomly selected chocolate bar will have less than 265. So less than 265. A refers to 1. So we're using the same formula we just looked at. Normal CDF, our low, our high, our mean, and our standard deviation. So we'll do normal CDF, negative E99, comma, 265, comma, 225, comma, 20. Now plug that in. So do second vars, normal CDF, negative E99, comma, 265, comma, 225, comma, 20, enter. And our probability will be 0.9772. Okay, number 6. To qualify for a police academy, applicants are given a test of physical fitness. The scores are normally distributed with a mean of 64. So mean is 64. And a standard deviation of 9. If only the top 25% of the applicants are selected, find the cutoff score. Okay, so we'll put 25% over here, and this will be 75%. And again, we're trying to find this value. So we're going to do INV norm, the area to the left, which is 0.75, comma our mean, which is 64, comma our standard deviation, which is 9. So do second vars, choose INV norm, 0.75, comma 64, comma 9, enter. And I'll take it 2 decimal places again. 70.07. Okay, number 7. Average number of milligrams of sodium in a certain brand of microwave frozen dinner is 600. So move 600. Standard deviation is 35. Assume variables normally distributed. If a sample of 50 dinners are selected, find probably that the mean of the sample will be smaller than 580. Smaller than 580. Here's 580. Smaller to be shaded this way. And we're talking about many, so we're going to be doing this formula. Normal CDF, our low, our high, our mean, our standard deviation divided by the square root of n. So we do normal CDF, low, which is negative E99, comma high, which is 580, comma mean, which is 600, comma standard deviation, which is 35, divided by the square root of, it says if a sample of 50 dinners. So n is 50. So let's plug that in. Okay, so we'll do second vars. I'll choose normal CDF. And I got negative second, comma 99, comma 580, comma 600, comma 35, divided by square root, so second x squared, 50. Enter. Okay, now we got 2.6669, 3 6s and 9, e negative 5. What this means is this is scientific notation. That e to the negative 5 means we need to move our decimal place 5 places to the left. So we got 1, 2, 3, 4, 2, 6, 6, 6, 9. Now if I were to round it to 4 decimal places, it'd be 0. So I'm just going to leave it this way. Just so we see it's not equal to 0. Okay, let's look at number 8. So the Gallup survey indicated 80% of 18 to 29-year-olds, if given a choice, prefer to start their own business rather than work for somebody else. It's telling us P is 0.80. A random sample of 200 is obtained, so n is 200. Ignore that section right there. Okay. In a random sample of 200 was probably no more than 72% prefer to start their own business. No more than 72%. So it's telling us p hat is equal to 0.72, and no more is shaded to the left. Okay. Well, let's go to our steps. Our first step is find moose of p hat, which is going to equal to p, which is 0.80. Then we have sigma sub p hat, which is equal to square root of p times 1 minus p over n. Okay, so that's going to be 0.80 or 0.8, whichever, 1 minus 0.80, all over n, which was 200. Let's see what that gives us. So do second x squared 0.8 times 0.2 divided by 200. And that gives us 0.02828422712. Okay, step 2. Convert that to z-score. So we got z is equal to p hat minus mu sub p hat over sigma sub p hat. Well, p hat is 0.72 minus mu sub p hat, which is 0.80, divided by sigma sub p hat, which is 0.02828422712. So to the beginning parentheses, 0.72 minus 0.80, close parentheses, divided by 0.02828422712. And assuming I typed them all incorrectly, I'll round this to 2 decimal places, negative 2.82. Okay, so then step 3. We're shading to the left, so this is going to be a normal CDF, negative E99, comma, the value we just found, negative 2.8201. And where that comes from is right here. The second one is when it's shaded to the left. First one is when it's shaded to the right, and the last one is when it's shaded in between two values. So let's see what that gives us. Second vars, choose normal CDF, negative E99, comma, negative 2.82, comma 0, comma 1, enter. And we get 0.0024. And that's our answer. That's part A. Part B. The random sample of 200 was probably 150 or less. Okay, so they're giving us x is equal to 150 or less, shaded this way. Well, we have to first find p hat. And p hat is equal to x over n. So that'll be 150, and n we said was 200. So 150 divided by 200 gives us 0.75. So what we're really finding is p hat is equal to 0.75 shaded to the left. Well, we don't need to do first step because it's the same as this. So we'll go directly to step 2. Z is equal to p hat minus mu sub p hat over sigma sub p hat. So we got 0.75 minus 0.80 divided by 0.02828422712. Okay, so do a beginning parentheses, 0.75 minus 0.8, close parentheses, divided by 0.028, assuming I can read my bad writing, 2842712. Enter. And I'll take it 2 decimal places, so we get negative 1.77. Okay, now our picture looks like this. We've got z is equal to negative 1.77, and I'm shaded to the left. So step 3, we're going to do normal CDF, negative E99, negative 1 point, can't read that says, negative 1.77, and then 0 and 1. So let's see what that gives us. Do second vars, normal CDF, negative second comma 99 comma negative 1.77 comma 0 comma 1. And we get 0.038, 4. And that'll be your answer.